Okay, great. So this is our final class before the holidays, and your case study is also kind of done. So I'm going to share it with you by the end of this week. And yeah, so there was a small change of the plan. So we had the case prepared by another company. The problem was there that they had some German textual analysis. So that's why I decided to create another case myself and share the case that I prepared myself to you. And when our guests will come after the holidays, they will present and solve the case for themselves, that you don't need to do it now. Yeah, but the case study is about the textual analysis of earnings conference calls. It's a topic that I really like, and I hope yeah, you will have enough time to do that. So the suggestion of the time for me is until the end of January. Let's see if you still need more time, but I think most of you could solve and finish it in 2 weeks of full work. Okay. Another point that I just wanted to mention is the presentations of the last week. So there was 3 presentations of auto EDA, and also the introduction of Sweet Viz and Pandas profiling. I didn't see many of you have still not watched it, so that's why I just want to stress it out, that these tools could be really handy when you, for example, have an unknown data set and you just want to get an idea of what's there. And with just 1 or 2 lines of code, you could already get a very nice report of the data quality, the correlations that could be interesting. And that's why it's worth watching this kind of videos. So yeah, for those of you that haven't yet watched it, please go and watch it. Okay, yeah. Then just very quickly, I just want to introduce today the Jaccard similarity and also wordclouds. So with these 2 parts, we will finish our NLP sessions. And yeah, hopefully in the new year, we'll start with another topic. Let's see. And then after like 20 minutes of my presentation, there will be a guest speaker, Sven Stadlow from Stuttgarter Versicherung, and he will come and discuss about asset management industry and how they use AI. Okay, any questions on the organizational stuff? Great. Okay. So what we had before was causal similarity, which was basically the whole idea was to create a vector out of the text and then see how different these 2 vectors are. So basically how what's the angle between these 2 vectors. Now we want to talk about Jaccard similarity. Here, the main difference is that we don't count the number of occurrences of a certain words. We basically see which words are there in a text. So for example, if text 1 has 4 words, text B has 5 words, we want to see the intersection and the union of these 2 sets. Basically, so we have a union of A and B, which is like basically all of them, and the intersection, which is only these 2, that is like a common word basically in both of the documents. And that's why we call Jaccard similarity as the intersection, which is 2 here, divided by 7, which is the union, and we call this Jaccard similarity. To give you an example how it works in Python, so assume that we have these 3 texts, text 0, profit, 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 loss, 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 and revenue. There are many repetitions here. And then we have text 1, cash, tax, revenue, tax, profit, and text 2 is asset, liabilities, cash. We go through the same process that we had always to create the document term matrix. So this DTM, oh, sorry. So the DTM is the document term matrix here. So for each document here, we see these terms. So in total, we have just assets, cash, liability, loss, profit, revenue, tax, and we can see how many times accord for each of the taxes. So we have 9 loss, 3 profits, 1 revenue, and tax 0, and so on. So how we define Jaccard similarity? So first of all, so just to stress it again, that so the number of occurrences doesn't matter for us. So when we want to see the first vector, we just replace any number above 1 to 1. So we basically say either 1 or 0. And then we define the intersection of the 2 vectors as the minimum of each column. So basically the intersection of 1 and 2 would be 0 here, a 0 here, 0 here, 0 here, but 1 here, 1 here, and 0 here. Okay, so the intersection should be 2 here in this for A and B, and the union is the same, but just the maximum. So basically, if here it's 0 again, but here is 1, 0, here 1, 1, 1, and 1. So we will have 5 in the union, we'll have 2 in the intersections. And so the Jaccard similarity would be 2 over 5. So this is, so let me define this Jaccard similarity, and we will do the same. So I hope. So this is our 3 texts. So we'll just see that text 0 and 0, they are the same, so they have 1. But the similarity of 1 and 0 would be 0.4 because there are many profit and revenue similarity here. Between 2 and 1 is a bit less because we have only cash that is there for both, and then yeah, for 2 and 2 it will be again the same because it's like they are basically the same. The most important thing is that when we have cosine similarity, because we have the vector, so that the count matters, because like if we have a higher number of a certain word, the length of the vector would be different. Okay, but here we don't consider the repetition of words anymore. So when you, for example, have the cases that yeah, 2 things, you just want to see the distinct words there, and you want to see the similarity based on the distinct words, then you should use Jaccard similarity. And the cosine similarity would be used mostly when you have very standardized text and there are like tiny differences there, and you just want to see, for example, yeah, so there are 2 comparable texts that you want to just compare. So they're most similar in the context, and they are standardized. Then you can use cosine similarity. Otherwise, usually Jaccard similarity would be a better approach to do that. Any question? Okay, so nice. Yeah, finally, I just want to show you how you could create word clouds in Python. So basically, word clouds are, I think, the only way you could easily picture the words available in a text. So basically, you say the text that we have. So we started with the Tesla annual report. That's why. So we see these words here. You basically need to use a library called wordcloud. You can install it by PIP, and it is based on Matplotlib. And so that's why you can do the same workarounds that you do with the Matplotlib objects. So you define a word cloud, basically saying that, yeah, I need a word cloud with this width and height, and the background should be white, for example, here. I don't want to consider the bigrams. That's why if you call it true, it will be not that beautiful. And then you can say, yeah, generate it from this text that I have. And it will generate the word cloud for you, and you just need to put this word cloud into the PLT object, and then it will show it to you. I have the documentation here. So basically you could make a lot of, so you have a lot of choices here when you want to create your word cloud. So for example, you can drop the stop words directly here and many other things that you can just directly do. One other thing that could be interesting for you is that, for example, you could have a mask. So for example, you could use a picture like this, and you use this mask and create the word cloud based on that. So you can see here masked word cloud. So you basically, based on any picture that you have, you can create your own word clouds on this boundary, for example. And this, the code is available for all of them, basically. Word clouds are very fancy ways to just picture the contents in a text. And yeah, it would be nice if you could do them very fast. And there's also another way to create the word cloud. So basically you can create it from the text. So it will be automatically done. Basically they will count the number of occurrences, and then it starts with showing all the words that are the most frequent there. You can also create them from dictionaries. So if you have a dictionary of like this, this word is with this frequency and so on, so you have a dictionary of many words, you could also create it from them. So that would be the same, basically. Yeah. Any questions on word clouds and so on? If not, it would be great. Let me see if we don't have yet the guess. Let me stop the recording.